Hello students, this is Neelam. Today we are going to study science subject basically for 10th standard, and this is session number 4 for the same chapter wherein we have been doing from the earlier. The chapter number 2, and the name of the chapter is acids, bases and salts. I repeat once again, acids, bases and salts is the name of the chapter, and it is a continuation belonging to the 4th session. Okay, now in this session we are going to study some important topic which is very important from your board point of view, board examination point of view, because whatever we are going to study over here, from this 2 or 3 questions are very importantly they will be going to ask for sure. Okay, now hereby we will start with it. First topic wherein we are going to study here is common salt. Common salt means the daily salt, the food wherein you are going to eat or consume, in that there is a salt. They are adding an edible salt which is nothing but called as NaCl. Alright, so commonly it is called as common salt. Right, sodium chloride is nothing but called as a common salt. Now common salt or raw material for chemicals. Common salt is becoming a raw material, initiation material to carry out certain reaction to form certain product. Understanding? So what is the meaning of the headline? The common salt is used as a raw material to form certain useful product. Right, so that is the meaning of the headline. Right, so common salt is nothing but NaCl is used as a raw material for the formation of certain product, useful product over there. Now how come this common salt can be used as a raw material for the formation of n variety of number of varieties of product over here, that we'll study here. Okay, now first point what it is saying is that the common salt thus obtained, the common salt, from where we are getting the common salt? We are getting the common salt from the sea, right? Ocean is salty in water. They have a salt content, large amount of salt content, right? So when they are just recovering the ocean water and just drying into the sunlight in a big pit, they are going to dry it, and after when the water is going to get evaporated due to the sun's heat, okay, so that time whatever is left over on the land is nothing but the salt. That salt in the heap they are going to recover. That common salt is not, later on if we are utilizing for eating purpose, it is iodized. So whatever the salt we are consuming over here, that is the iodized salt which is having iodine content into it. But the common salt, when they are just removing from the employed process, that common salt can be used for the different varieties of procedure, different procedures, so that you can get the n number of products from that. Okay, now let's understand that. Now the common salt thus obtained, the common salt wherein you are obtained from the ocean, is very important raw material. It is very important raw material for various materials of daily use such as NaOH. Now NaOH is the most important. How NaOH can be obtained from NaCl, that we'll study on later on here. Okay, now first thing is that the common salt is very much useful. It is used as a raw material for obtaining NaOH. Second one is bleaching powder, washing powder, right? So all these things can be recovered from NaCl, can be obtained by using NaCl as a raw material. Understanding my point? So these are very important. Bleaching powder, washing powder, then baking powder, right? So this can be used, this can be obtained when NaCl is used as a raw material over there. Okay, so that is the first more important point. First point is saying that common salt is very important, and it is used as a raw material for obtaining products such as NaOH, bleaching powder, washing powder, then baking soda or baking powder, it is also called as baking powder. So these are the ingredient wherein can be obtained by using NaCl. Now let's understand how NaOH, sodium hydroxide, can be obtained by using NaCl solution. Now NaCl solution is also called as a brine solution. I repeat once again, brine, B-R-I-N-E. Brine. So NaCl solution, if I use the word solution, solution means what? So salt is added into the water. A small amount of salt has to be added into the water to form a solution, right? So that is called as a NaCl solution. Now here brine solution, if they want to use to recover NaOH, they will take obviously in a certain amount how much NaOH has to be recovered. Depending upon the amount of NaOH they have to be recovered, that much amount of NaCl solution they will be going to use. Okay, let's understand how NaOH can be obtained by using brine. Now instead of using NaCl solution, I will use the word brine solution. Okay. Okay, now sodium hydroxide. Sodium hydroxide, the molecular formula for sodium hydroxide is NaOH. Now if I want to get NaOH, the first raw material wherein I am going to use over here is common salt solution. Common salt means NaCl solution, which is brine solution. Okay, now here you can see in this diagram, you can see one container is there, yellow color container which I had been drawn over there. In that one container is there, right, and inside that there are certain materials. I'll explain you everything in more detail over here. Now this container is nothing but called as electrolytic cell. What it is called as? It is called as electrolytic cell. Now this electrolytic cell is composed of electrode. These are electrodes, two electrodes, anode and cathode. Anode and cathode. So these are electrodes. These electrodes are solid in nature. These electrodes are solid in nature. They may be in rod shape, they may be in plate shape, right? So these are the electrodes which are solid in nature. Now these electrodes have been dipped or immersed into a liquid medium called as electrolyte. Now this you can see over there, right? So this is nothing but the electrolyte, and this electrolyte I am using the word, it is a solution. It is the aqueous solution of certain ingredient. Now if I am using the word solution, which solution we are using over here? What we are recovering? We are obtaining NaOH from where? From brine solution. Now what is brine solution? Brine solution is nothing but NaCl solution, right, which is added solution. If I am using the word solution, NaCl is added into water to form solution. NaCl is a solute and the water is a solvent. So when this solute and the solvent is added, they will form the solution. Understanding my point? So this is a solute, this is a solvent. Solute plus solvent will give you solution, right? So this is the NaCl solution which is formed in the aqueous form. Now this NaCl solution, when I am adding into the container, electrolytic cell container, this is considered to be electrolyte. So I repeat once again, the container wherein I took over here, it is called as electrolytic cell. Now in that electrolytic cell, two rod shape or plate shape electrodes are used, and those names are anode and cathode. Right, so these electrodes whose names are anode and cathode, they are dipped into a solution called as electrolyte, and that electrolyte is basically nothing but NaCl solution. NaCl solution is also called as brine. Okay, B-R-I-N-E, brine. Okay, that was the setup. Okay, now this anode and cathode, these are the electrode. Now this anode and the cathode has to connect it to the external battery. So anode is connected to the positive terminal of the battery, whereas cathode is connected to the negative terminal of the battery. I repeat once again, anode is connected to the positive terminal of the battery, whereas cathode is connected to the negative terminal of the battery. Okay, now this is the apparatus, this is the setup wherein we have been used for recovery of NaOH from the brine solution. Now let's understand how it's work. How the process is going on in this electrolytic cell. We understood what is a setup and what it contains. Now we'll understand the mechanism, the process which is going on into this cell. Okay, now as I said, we are going to recover NaOH by using NaCl solution, brine solution. Now here sodium is there, chlorine is there. Now this water can be splitted as, how the water is splitted? Water is splitted as HOH, H plus ion, OH minus ion, right? So these are the ions which are present. Which ions? Sodium ion is there, chlorine ion is there, hydrogen ion is there, hydroxyl ion is there in the electrolyte. Correct. So this electrolyte is containing these ions. So when these ions are splitted, then only the electrons can be passed into it, right, to form the NaOH. Now here you are going to recover NaOH, right? So here let's understand this point wise, then this mechanism will be understood more easily over there. Now when the electricity is passed through the aqueous solution of NaCl, when the electricity, who will pass the electricity? The electricity obviously passed from this battery, right? So when the electricity is passed through the aqueous solution, so this is the aqueous solution. Aqueous means water is added into NaCl. That means NaCl has to be poured into the water to form NaCl solution, right? So aqueous solution of brine, in the bracket it is written over there, aqueous solution of brine. So it decomposes, this brine will be going to get decomposes to form NaOH. That brine, what is that brine is consisting of? Na plus Cl minus, right? So this will be going to get decomposed totally, it will be going to get splitted into ions to form NaOH over there, right? So this process is basically called as chlor-alkali process. Chlor-alkali process. This process is also called as chlor-alkali process. Now how this decomposition of NaCl will be going to take place? Let's understand by taking an reaction. Now in this reaction you can see, children, now two molecules of NaCl. Now this is a brine solution, right, which is containing two molecules of NaCl. Let's understand from the two molecules here. Now when two molecules of NaCl is reacting with the two water, now water I had splitted so that it becomes very easy for you to understand. So two molecules of water, HOH, right, H2O, no? So this is H2O, correct? So here this 2 sodium will react with the 2 hydroxyl. So this, if I am writing 2 in front of HOH, that means this 2 is applicable for 2 hydrogen and applicable for 2 hydroxyl ion. Okay, now this 2 sodium will react with this 2 hydroxyl to form 2 NaOH, right, to form 2 NaOH. So 2 sodium reacted with the 2 hydroxyl to form 2 sodium hydroxide. Understood this point? Now remaining, what is remaining over here? Here 2 hydrogen is remaining and 2 chlorine is remaining, right? So this will combine together, right, or they will be going to get, not going to get combined. In fact, they are going to form the gas over there. They are going to form the gas. So the gaseous molecules wherein they are going to get escape is nothing but this is 2 hydrogen gas, H2, and this is 2 chlorine. Right, so these are going to get escape outside the lid, but first they are going to get decomposed at the respective electrode and they are going to get escaped out later on, right? So this is the reaction. What the reaction is saying, let's understand once again over here, right? So let's understand here once again. I'll write it down so it becomes more precise for you guys too. Okay, now what we used? 2 NaCl. We had added 2 molecules of NaCl. Now it is reacting with 2 water molecule, right? 2 water molecule. I am splitting in this manner. 2 NaCl is added with 2 water molecule. So what is the main product wherein we are going to recover from NaCl? Sodium hydroxide. So this 2 sodium will react with the 2 hydroxyl, right, to form 2 sodium hydroxide, correct? This we have been recovered. NaOH has been recovered, correct? Now what is remaining over here? 2 hydrogen is remaining, 2 chlorine is remaining. Now this 2 is applicable for 2 sodium and as well as for the chlorine. So what is going to get escaped as is nothing but the gas, the chlorine gas as well as the hydrogen gas, right? So this will be going to get escaped out as hydrogen gas along with chlorine gas. Understood the point? So this is very, very important. This is how the brine solution or NaCl solution will be going to get decomposed. Decomposed means splitted to form the sodium hydroxide. Right? So this is how the recovery of the sodium hydroxide will take place from the brine solution. Okay, now this hydrogen gas and the chlorine gas which has been formed in the reaction, they have to go towards the electrode, respective electrodes. Now the chlorine gas, first we'll understand from the chlorine gas. Now the chlorine gas is given off at the anode. So this chlorine is there, this is the chlorine wherein it will go towards the anode. This is the anode. Anode is the electrode. So towards the anode, this chlorine gas will go and get decomposed. Why chlorine will go towards the anode? Because chlorine is nothing but it is an anion. right? If I take in the form of ions, it is considered to be chloride. If it is considered to be chloride. So this chloride ion is negatively charged species. Negatively charged species ions are called as anion, right? So this chlorine ions will go towards the anode, whereas this hydrogen, right, H plus ions will go towards the cathode to form hydrogen gas over there. This chlorine ions will go towards the anode to form chlorine gas, whereas hydrogen ion, which is positively charged ion called as cation, will go towards the cathode to form hydrogen gas over there, right? So this is how the chlorine gas and the hydrogen gas will go towards the respective electrode, and from there they are going to get escape out. You can see here in the diagram. Okay, so this is all about how the sodium hydroxide is recovered from the NaCl. So this is very important chemical reaction, because this reaction only says how sodium hydroxide is recovered from the brine solution, right? And whatever the gases has been formed over there, they will go towards the respective anode and the cathode. But remember, chlorine will go towards the anode. Why it will go towards the anode is that because this chloride ions they are negatively charged ions. They are called as anion. Negatively charged ion, anion, will go towards the anode. You have to remember, they will go towards the anode, whereas positively charged cation, they will go towards the cathode. Understanding? So thereby chloride ions, when they go towards the anode, they will combine together to form chlorine gas, whereas cation, hydrogen ions, when they are going towards the cathode, they will combine together to form hydrogen gas. That is a different process. But right now at 10th standard level, you have to remember only one thing is that chlorine gas is formed at the anode, whereas hydrogen gas is formed at the cathode. That's it. This much is there in your textbook. That only you have to remember right now over here. So this is how the children, the NOH is formed from the NaCl. So this is from here beginning we are going to study by using NaCl as a raw material how the different product can be recovered. Now we have been understood how NaOH is recovered from the NaCl. Now we'll study how bleaching powder, how washing powder can be recovered by using NaCl as an ingredient. Okay students, now we are going to study how NaCl or common salt is used for the production of another ingredient or another product. The name of the first ingredient or the product to form by using sodium chloride as one of the raw material. Let's study that. First one is bleaching powder. Bleaching powder. How the bleaching powder can be produced by using NaCl, right? Or by using calcium hydroxide, which is a slaked lime. Okay, now chlorine, which is produced during the electrolysis process. First understand what are the raw material used over here. In bleaching powder, chlorine, which is produced during the electrolysis of aqueous NaCl brine solution, right? Now earlier, just now we studied that how sodium hydroxide is produced by using NaCl. Now in that the chlorine and hydrogen gas is formed, right? Whereas the chlorine was formed at the anode, hydrogen gas was formed at the cathode, right? I think you are remembering that. Now these gases which are escaped from the reaction, from the process, those two gases are used over here for the formation of, bleaching powder. Okay, now the chlorine which is produced, the first statement is very important. The chlorine which is produced, now basically from hydrogen also they are using chlorine rather than hydrogen, right? Maybe the hydrogen they are using for some other purpose, but the most important, the chlorine is used over here. The chlorine which is produced during the electrolysis, that process wherein we studied was electrolysis of aqueous brine solution, right? It is used for the manufacturing of bleaching powder, right? So chlorine which has been produced after the process of electrolysis from NaCl, that chlorine gas is used as a raw material for the formation of bleaching powder. That is a statement. Now the second statement is that bleaching powder is produced by the action of chlorine. By the action of chlorine. From where we are getting that chlorine? Chlorine was formed from the electrolysis process on slaked lime. Slaked lime, as I said, it is nothing but calcium hydroxide. So that chlorine gas, they will pass through the slaked lime to form a bleaching powder over there. Now let's understand by taking the reaction over here. Now what they took is calcium hydroxide. Calcium hydroxide is nothing but it is a slaked iron. So let's take calcium bracket hydroxide ion. So this is a calcium hydroxide which is a slaked lime. Now to this they are passing chlorine gas, correct? They are passing chlorine gas. Now when they are passing chlorine gas, from here first you just have to recover by removing water molecule from it. You just remove the water molecule from here. Now how you will remove the water molecule? The water molecule can be formed when 2 hydrogen and 1 oxygen from here will be going to get removed off. So if from here only the water molecule will be removed off. How come? How come H2O is formed? 2 hydrogen and 1 oxygen. 2 hydrogen will be going to get come out and 1 oxygen. How many oxygen is left over here? 1 oxygen, right? If I am writing 2 has a subscript, this 2 is applicable for oxygen as well as for the hydrogen, correct? So out of this 2 hydrogen will be come out as well as 1 oxygen will be going to get recovered to form a water, right? So how many oxygen is left here is 1 oxygen and no hydrogen over there, right? So what is left here again is calcium is left, 1 oxygen is left and chlorine is left. Understood my point? So this calcium, 1 oxygen and chlorine all together they will combine to form a bleaching powder. So this is a bleaching powder. How come the bleaching powder has been formed? By reacting calcium hydroxide with the chlorine gas, right? So from this you just have to remove the water molecule. The water molecule will be going to get recovered. So what is left in the bracket is only the oxygen. That calcium oxygen will combine with the chlorine to form a bleaching powder, right? So this is what about the bleaching powder is formed. So the most important raw material we have been used over here is a chlorine gas. From where we are getting the chlorine gas? Chlorine gas we have been recovered from the electrolysis process of brine solution. Okay, that was the formation, right? Okay, then after that we'll study now where the uses of bleaching powder will be going to take place, right? So bleaching powder uses where this calcium, oxygen and chlorine oriented compound is used for bleaching cotton and linen in the textile industry, right? So in fabric industries this bleaching powder is used. Fabric industry means basically in cotton industry as well as linen industry. These are the fabrics, right? So in order to bleach it, the bleaching powder is used over there, right? So for bleaching cotton and linen in the textile industry, fabric industries. Now that is the first use. Second use is to make drinking water free from the germs. Now whatever the drinking water we are drinking, that has to be, if I meant to make it free from the pathogen or germs, the bleaching powder is used over there. Understanding my point? So to make drinking water free from the germs or pathogen, that is the second use of bleaching powder. Third point, for bleaching wood pulp in the paper, right? In order to bleach out the wood content on the, from where we are getting the paper we are recovering from the wood itself, right? The bamboos in the forest, from the forest only, right? So forest is becoming a resource for the paper production. So from the wood only we are getting the paper. So in order to bleach that wood, bleaching powder is used, basically the pulp of the wood, right? So bleaching powder is used. And one more is the use of bleaching powder is nothing but it is used as an oxidizing agent in many chemical industry. It is used as an oxidizing agent in many chemical industries, right? So these are the uses of bleaching powder. So first use of bleaching powder is that it is used for bleaching linen and cotton into the textile industry. Second is to make drinking water free from the germs or pathogens. Third one is it is used to bleach the wooden pulp to recover the paper while making the process of paper making, right? So apart from that, it is also used as an oxidizing agent in the many chemical industries. Okay, so these are the uses of bleaching powder and how bleaching powder is formed by reacting with the calcium hydroxide. So in examination you may get the question, right? Write down the short note on production of bleaching powder, right? So you are supposed to write 2-3 points. Along with that, this reaction is very, very important. If you are not supposed to write this reaction, your marks will be going to get reduced over there, right? Then exceptionally 2 marks or 3 marks question will be there for the uses of bleaching powder, where it is used, right? So these are the uses of bleaching powder. Now apart from that, now we'll study Okay, now we are going to study how the baking soda is formed by using NaCl as a raw material. The chemical name for the baking soda is sodium, hydrogen and carbonate. Sodium, hydrogen and carbonate. So how you will be going to form this sodium, hydrogen and carbonate by using NaCl? Let's understand this. Now here, what is the first ingredient we are going to use here is NaCl. Right, so in this NaCl we are going to add another ingredient along with that. The second raw material is water. We are going to add water into it, right? And then apart from that, we are also going to add carbon dioxide gas and then ammonium. So these are the raw material wherein we are going to use to produce ammonia, sodium, hydrogen, carbonate, which is a baking soda, right? So I'm going to form the sodium, hydrogen, carbonate by using all this thing. So sodium, what is the main important thing which need to be recovered from all this thing is sodium first, hydrogen and then carbonate. We are going to get sodium from NaCl, right? For sure. Chalo, write down along with me. I got Na from NaCl. Now second, what I need? Hydrogen. Hydrogen I'm getting from here. Okay, chalo, write down along with that hydrogen. Now what we need is carbonate. We are getting carbonate from where? Carbon dioxide and one oxygen, correct? So what we got is sodium, hydrogen, carbonate, right? So this is the main product wherein we are getting it. But along with that, the remaining thing which is there, what is remained over here? NH3 is remaining, which is ammonia. And what is left over there? Chlorine is left, along with one hydrogen is also left. Right, so ammonia is left, one hydrogen is left and one chlorine is left. So all this will be going to get combined to another byproduct which is ammonium chloride, right? So what the thing has been produced over here is sodium hydrogen carbonate. How sodium hydrogen carbonate is formed? By taking NaCl, water, carbon dioxide plus ammonia, right? So here from sodium chloride we are taking Na, hydrogen and carbon dioxide. So we have been recovered all those things to form, along with that one oxygen is also added, right, to form NaHCO3. So whatever had been circled, we have been extracted to form sodium hydrogen carbonate. And the remaining thing, whatever I had tick marked, that are the remaining thing. They will combine together to form ammonium chloride. Okay, so I repeat once again how the baking soda is formed. Baking soda is formed by utilizing NaCl, second water, third carbon dioxide, fourth one is ammonia. So this 4 raw material is used to form NaHCO3 along with NH4Cl, which is ammonium chloride. Okay, that was the first production how the sodium hydrogen carbonate is formed. But the sodium hydrogen carbonate or the baking soda is also used during cooking process. When they are heated, that it will be going to undergo decomposition to form another product. Let's understand that by taking the chemical reaction over here. Now if I am taking 2 sodium hydrogen carbonate molecule, right? So during cooking process it is heated, right? It is heated. Then it will form certain another product. The main product it will be going to form over there is, no doubt, it is sodium carbonate. Sodium carbonate. So now here 2 sodium is there, 2 hydrogen is there, 2 carbonate ion is there, right? So out of all the 2 atoms of sodium hydrogen carbonate, here first thing is sodium carbonate is formed, right? So 2 sodium I had recovered, then 1 carbonate ion, 1 carbonate is recovered. So what is left? The remaining thing, they will react with each other to form water plus carbon dioxide gas. So let's understand how this reaction is taking place. Now this 2 sodium NH2 will come to react with 2 carbonate ions. They will react with carbonate ion to form sodium carbonate. Now out of this 2 carbonate, 1 carbonate has been recovered. 2 hydrogen is left. So what is left? That one will write down. What is left over? 2 hydrogen is left, 2 carbonate is left. Correct? 2 hydrogen is left and 1 carbonate is left. 1 carbonate ion is left. Now here in this carbonate ion CO3 is there, no? From oxygen, 1 oxygen will combine with this right, to form water, and the remaining 1 or 2 oxygen will remain as it is to form carbon dioxide gas, right. So in this manner you can remember. Or other way around, when 2 molecules of sodium hydrogen carbonate is decomposed, it will form sodium carbonate, water plus carbon dioxide. This is the first step to remember. Or the second step is that from sodium hydrogen carbonate, for sure sodium carbonate will be going to get extracted, but the remaining what is left is there 1 carbonate ion is left and 2 hydrogen is left. So from 1 carbonate 1 oxygen will go and combine with the hydrogen to form water, and the remaining one will be the forming carbon dioxide. So these are the 2 steps for you guys to remember it, right. So this is nothing but how the reaction is taking place when the baking soda is formed and when the baking soda is used during cooking. Now during cooking process, like while making pakoras, while making cake, so baking soda is used over there in order to make that foodstuff very fluffy or soft, right. So this baking soda, when they are using, the carbon dioxide gas will be going to get escaped out in order to make have the pores on that foodstuff, and it becomes very fluffy over there, understanding, and soft also. So that was all about how the baking soda is formed. So what we studied over here, children, is that first thing is that we studied how the bleaching powder is formed by using chlorine gas as one of the raw material, and it is reacted with the calcium hydroxide, a slaked lime, to form a bleaching powder, okay, along with the water. Now what are the uses of bleaching powder also we studied, right. Apart from that, we studied how baking soda is formed. Baking soda is formed by using 4 important ingredients, which is first one NaCl, second one is water, third one is carbon dioxide gas, fourth one is ammonia. Right. So this ingredient will combine together to form NaHCO3, along with that NH4Cl. And then in second step we studied when sodium hydrogen carbonate is used during cooking, then what is the product, how it will decompose to form sodium carbonate, water and carbon dioxide gas. Okay, now we are going to study what are the uses of baking soda. Now earlier we have been saw that how the baking soda, which is nothing but sodium hydrogen carbonate, is formed by using certain ingredient. But now we are going to use the uses, where it is basically used, the uses of baking soda. Now this sodium hydrogen carbonate is an ingredient which is used as an antacid. Now antacid means what? Whenever excess acidity is happening in the human body, excess acidity means what? Whenever the excess amount of hydrochloric acid is released in our tummy, in our stomach, that time we have irritation, pain, stomach ache. These are the symptoms wherein it is happening, right. A mild chest pain also. So if this acidity is occurring, that time what we are consulted to take? We are consulted or recommended to take antacids. Now antacids are nothing but those are the tablets which contain sodium hydrogen carbonate as a main ingredient, a baking soda, right. Along with that, the normal baking soda which is there in your home, if you just pour that powder into the water and drink it out, you will feel relaxed or relief after a certain period of time, right. So this is used as an antacid, sodium hydrogen carbonate, which is a baking soda used as an antacid, which is used to neutralize, very important point over here, it is used to neutralize the acid secretion in our tummy, right. Why it will neutralize? Neutralization reaction here. When acid react with base, it forms salt and water. Now which is the acid which is secreted in our tummy? HCl, hydrogen chloride or hydrochloric acid. This is acid secreted in our stomach. But along with that, when a base, which is sodium hydrogen carbonate, it is a basic in nature. So when acid and base react together, it will form salt and water. So that is neutralization reaction. So the base, which is called as sodium hydrogen carbonate, it will neutralize the acidity which is occurring in our stomach. So that is the first use. Now second use is it is used in soda acid fire extinguisher. Now whenever fire extinguisher, the red color cylinder which is used to extinguish the fire, right. So in that the sodium hydrogen carbonate powder is used because it releases carbon dioxide gas, right. You have been seen when sodium hydrogen carbonate is decomposed, carbon dioxide gas is released. That carbon dioxide gas is nothing but the extinguisher which is used to extinguish fire. It cuts off the fire from the atmospheric oxygen and thereby the fire will be going to get extinguished. right? So sodium hydrogen carbonate, baking soda is used as one of the ingredient in fire extinguisher, right? So these are the two important uses of baking soda. First one is it is used as an antacid to neutralize the acidity in the human body. Second point is it is used as the most important ingredient in fire extinguisher. Okay, so these are the two important uses of baking soda. Now let's understand what is washing soda. Now do not get confused between baking soda and washing soda, right? Now baking soda is sodium hydrogen carbonate. Washing soda is sodium carbonate, and along with that 10 water molecule will be there. I repeat once again, baking soda is sodium hydrogen carbonate, whereas washing soda is sodium carbonate, but along with that water molecule will be there some, right? So now let's understand what is washing soda. Now washing soda is nothing but it is a recrystallization of sodium carbonate. Now what is recrystallization? Crystallization. Now crystallization is nothing but some amount of water molecule will be associated with that salt. Some amount of water is associated with a particular salt, right? Now sodium carbonate is a salt. It is a salt. Along with this, some water molecule will be there. Some water will if we add sodium carbonate with certain amount of water, it will be converted into washing soda, right? Now if I take, let's understand by taking an reaction. Sodium carbonate, when it is treated or added with the 10 water molecule, right? 10 water molecule, here the compound is formed which is nothing but washing soda, right? So the product will be written as Na2CO3, and how many water we added? 10 water molecule, right? So dot 10 H2O, right? 10 H2O, right? So this is a washing soda. This is a washing soda whose molecular formula will be Na2CO3. Along with that 10 water molecule is there, right? So what is this? It is a recrystallization of sodium carbonate salt. So in this sodium carbonate salt, when I add 10 water molecule, it will form washing soda whose formula will be Na2CO3, 10 water molecule, right? So this is all about the washing soda. Now where it is used, the uses of washing soda. Now it is used in a glass industry, soap industry and paper industry. The most famous use of washing soda is in making glass, soap as well as in paper industry, right? Okay, that is the first use. Now second use is that it is also used in manufacturing of sodium oriented compound called as borax. So for manufacturing borax, washing soda is used. Then apart from that, third point is in removing permanent hardness of water. In order to, if I want to convert the hard water into the soft water. Now what is hard water? Hard water is that water which contain n number of salt into it. You cannot see the leather or foam or leathers from the soap. So when you rub on the cloth or on your skin, when you are utilizing hard water, you will see certain scum formation. The leathers or the foam will be not going to form over there. Understanding? So hardness of water can be removed by adding washing soda, right? So that is the third use. Okay, now first use is it is used in glass, paper as well as soap industry. Apart from that, it is used in manufacturing of sodium oriented compound called as borax, as well as it is used in removing the permanent hardness of water. So in order to convert that hard water into soft water, washing soda is used over there. Okay, so that was all about the production and the uses of washing soda. Now let's go towards the water of crystallization. Water of crystallization is nothing but some amount of water will be associated with the 1 unit formula of salt. 1 unit formula of salt. If I am taking 1 unit formula of salt, and if I am adding water molecule, that will be converted to that can be said to a water of crystallization present into that particular salt. Okay, let's see what it is. It is fixed number of water molecule. It is water of crystallization is nothing but it is a fixed number of water molecule will be present in 1 formula unit of salt. In 1 formula unit of salt. So in 1 formula unit of salt, in particular formula unit of salt, fixed number of water has to be added over here. Now if I add 10 water molecule, 10 molecules of water approximately over there, that time you will get the washing soda over here. Similarly, here now water of crystallization is nothing but fixed number of water molecule will be present in 1 unit formula of salt, right? Suppose let's take an example of copper sulfate. Now copper sulfate is having a molecular formula CuSO4. Now this is a salt, 1 unit formula of a salt. Copper sulfate is a 1 unit formula of salt. In 1 unit formula of salt, I need to add 5 water molecule, right? So it is pentahydrate. So that penta means 5, right? So 5 water molecule is fixed or associated with the copper sulfate to form hydrated copper sulfate, or water of crystallization is present within that copper sulfate. Okay, so that was all about the water of crystallization. Now let's move towards the next topic, which is plaster of Paris. This is very important concept from examination point of view, plaster of Paris. Now how plaster of Paris is formed and where it is used, let's understand. Now plaster of Paris is formed by heating one kind of a compound called as gypsum, right, which is gypsum. Gypsum is nothing but here 2 water molecule will be present with the copper sulfate, right, sorry, calcium sulfate. It's not copper sulfate, it is calcium. Ca stand for calcium, Cu stand for copper, right? This is a huge difference between copper and calcium. Now gypsum is nothing but here 2 water molecule, a fixed number of water molecule, which is 2 number of water molecule will be present within a 1 unit formula of salt, which is calcium sulfate, right? So in calcium sulfate 2 water molecule will be present. So this is nothing but called as gypsum. Now when I am heating this gypsum at 373 Kelvin, right? So that time, right, out of 2 water molecule, 1.5 water molecule will be evaporated. 1.5, when 2 is there, and in the product you can see only half is there. H2O is remaining as it is. H2O is remaining as it is. So where the difference is there, from 2 it has been converted into half, right? So from 2 water molecule, 1.5 water molecule has been evaporated to form a compound called as plaster of Paris. And the formula for plaster of Paris is nothing but calcium sulfate, and it is hemi-hydrated. Hemi means half, right? Hemi-hydrated means half water molecule is present. This is nothing but called as a plaster of Paris. So if anybody is saying you to write down the chemical formula for plaster of Paris, calcium sulfate hemihydrate means CaSO4, half water, right? H2O, half H2O, and gypsum is nothing but calcium sulfate with 2 water molecule. Now in examination you may get how you will form gypsum from plaster of Paris. Now this is the one reaction. From gypsum you are forming plaster of Paris. From gypsum you are forming plaster of Paris. Now if anybody asks you how you will form gypsum, right, from plaster of Paris, so this is exactly the reverse process. The reverse process is like now when a plaster of Paris, this is a plaster of Paris, POP, plaster of Paris, POP, which is a white color powder. If I add water, 1.5 water molecule, 1.5, exactly 1.5 water molecule, right? So this is half, 1.5 becomes 2. So this is a reverse process, right? So if plaster of Paris is added with a water molecule or hydrated with the water molecule of around 1.5, so that time it will be going to get converted into gypsum, which is a hard solid mass, right? So how the gypsum will be going to form? Calcium sulfate with 2 water molecule, right? So this will be the formula for gypsum, right? So from plaster of Paris you can convert it to gypsum, or from gypsum you can convert into plaster of Paris. You just have to understand what is gypsum and what is plaster of Paris. So gypsum, when you heat at 373 Kelvin, right? So out of 2 water molecule, 1.5 will be going to get evaporated, and remaining half is left. So that's nothing but calcium sulfate hemihydrate is nothing but plaster of Paris. And now in that plaster of Paris, again if you add 1.5 water molecule, it is converted into gypsum, right? Reverse reaction it is. So you may expect, you may have this kind of a question, right? The formation of plaster of Paris. What is plaster of Paris? That time you are supposed to write this reaction. Along with that, 2 or 3 statements is supposed to be written over them. Okay, that was all about this. Now we studied over here the uses of baking soda. Along with that, the production of washing soda, how the washing soda is produced by recrystallization of sodium carbonate, and then what are the uses of washing soda. Apart from that, what is water of crystallization, and then plaster of Paris, right? So do not get confused between baking soda and washing soda. Baking soda is nothing but sodium hydrogen carbonate. Washing soda is nothing but sodium carbonate with 10 water molecule into it, right? So this is a huge difference between the baking soda and the washing soda. Okay, now we have been winded up with this chapter, right? This is a little huge chapter, but it is very important from higher standard point of view also, because these are all basics, right? And from this a maximum number of questions are expected to come in the board examination. So make very much thorough with the concept, as well as keep on reading or practicing the reaction by writing in the book, so that will make you more perfect over them. So apart from that, I hope that you guys have been understood this chapter very well, and I hope we'll start with the next chapter immediately after this session. So thank you class for watching this class. So have a nice day. Thank you.